This lesson covers one of those topics that can confuse even math teachers at first, but it addresses the question of why do we get a plus or minus in our answer when we solve quadratic equations but not radical equations. And this confusion comes from a couple different things. Mainly it mixes up evaluating with solving. So on this side we're going to look at solving a quadratic and a rational equation. So we're going to look at two similar ones. We're going to talk about x squared equals 16, and we'll just do a simple one, versus the square root of x equals 4. And then on this side, we're going to look at evaluating. And we're going to look at the square root of 16, and we're going to look at 4 squared. So on the solving side, we've got a quadratic, and we've got a radical. And over here, we're just evaluating some expressions, the square root of 16 and 4 squared. Where this confusion comes in is people want to say that the square root of 16 is positive 4 or negative 4. And the reason for that comes from solving a quadratic. If we're looking for x, when we've got x squared equals 16, our first step is we're going to take the square root of both sides. So you notice here we've got the square root of 16 just like we had over here on the right side. But we're told that when we take the square root of both sides, we're solving and we're getting positive or negative 4. Now the reason for that is we're not dealing with a radical or a square root here. We're dealing with a quadratic. We'll get back to that in a second. Let's look at the radical equation. We've got the square root of x equals 4. So now we're going to square both sides, and we get that x equals 16. We don't need a plus or a minus there because we're not taking the square root of both sides. We're squaring it, and the only answer you get when you square 4 is 16. You don't get negative 16 when you square 4. So now we want to plug these back in. And here's where this should hopefully make sense. We've got two different answers. We've got positive 4 and we've got negative 4. So let's plug it back into our original equation. We're plugging it in for x, so we've got x squared there. We're going to plug in 4 equals 16, and 4 squared is 16, which checks out. And we're going to plug in our second answer, which was negative 4. So negative 4 squared, negative 4 times negative 4 is 16. That checks out. So now let's plug our answer back into the radical equation. We've got the square root of 16 equals 4. The square root of 16 is 4. But we're trying to make positive 4. If we took the square root of 16 and said negative 4 is not equal to 4. So that wouldn't work out if we plugged in both the negative and the positive answer. So that takes us to evaluating. When you take the square root of 16, some people want to apply the rule for solving a quadratic and apply that to evaluating a radical. But with this one, we're just getting the principal root of 4, not negative 4. In order to get negative 4, we would need the negative on the outside of the radical, which gives us negative 4. 4 squared is always going to equal 16, just like negative 4 squared will also always equal 16. And this gets into the definition of a function, which says that every input has exactly one output. That applies here. When we plug in 4, we get 16. But we're always going to get 16 when we plug in -4, we still get the same number 16 as the output, but this input has one specific and unique output. If we applied that here, if we plug in 16 as the input of our radical, we're only going to get one output of 4. We would violate the rule of a function, or the definition of a function, if we also got -4. So that's a different topic, looking at inverse operations and quadratics and radical equations, which we can talk about in another topic. But I hope that clears up some confusion on why we only get plus or minus when talking about quadratic equations and not when we're solving radical equations. I hope that helps. If you enjoyed that answer, please subscribe to my video, and thank you very much.